Assalamu alaikum. In this tutorial, we are going to see how to assemble the spring suspension system like the one shown in this figure. Here we can see that we have total 4 components. This is the cylinder part, this is the cylinder head, third one is the nut, and finally the fourth one is the spring. So in order to assemble this, uh, what we saw in our class is that there could be two possibilities. First one, as shown in this video, that the spring compression and elongation is done with the help of this nut. So this nut will have a screw mate on this cylinder, and when you play the animation, the the nut will also rotate, and as well as the spring that is shown in this video. And the second option could be that the nut is no longer rotating in the animation. However, the elongation and compression of the spring is done with the help of the cylinder head. So this is the usual scenario that we encounter when a normal shock absorber is in service. So according to our class, we will try to assemble in a way that the nut is fixed and the shock absorber will move with the help of this cylinder head. So let's get started. Here in SolidWorks, we have already opened all 4 parts. Now you can go here, click on New Assembly. So as soon as you open the assembly, on the left panel, all the parts are listed. With the help of Control key, you can select them all and then click on the canvas. So our first part is the cylinder. Second is the cylinder head. Third is this nut. And finally the spring. Once you have placed all the parts, you can start creating mates to assemble them. Now, in order to start the mating process, first of all, what we need to do is we need to have the orientation of the cylinder and the cylinder head uh, opposite to each other. So first of all, what can we do is we select the cylinder from this tree and unfix this component. So click on float. This was the first component in our assembly, so that is why it was fixed by default. But now we have made it free, so you are able to move it and rotate it as well as per your requirements. So we just selected this part and now click on rotate component. From the rotation drop down menu, select by delta XYZ and rotate it about the x-axis 180 degree. Just click on apply and it is rotated. Similarly, this nut is also to be rotated because it has two faces. One is the flat surface, the other one is curved surface. When we will attach it with the spring, we will need to have a flat surface so that it is easily attached with the help of mate. So we select it and also apply the orientation 180 degree about x-axis for this part. So just select this part, 180 is already there, just click on apply. So it is also rotated. Now we can come out of the move component parts and now start mating. So first of all, we go here to mates and we can select this circular face of the cylinder and this circular face of the cylinder head and just click on concentric. So now these two parts are concentric. Just click OK, come out of the mates. And since in our assembly we have decided that the spring will elongate and compress along with the cylinder head, and nut will be fixed. So we can say that this part can also be fixed here. So after the rotation is complete, we can again fix this cylinder. We do not want it to go anywhere, whether in rotation or in translation. Our next job should be to put this nut on these threads. So again, click on mate, and this time we need to have a temporary axis visible so that we can select the temporary axis of this nut as well as the temporary axis of this cylinder. So both of these axes are selected, and now this nut has been aligned with the temporary axis. Just click OK, come out of the mates, and now you can see that you are able to, once you select the face, then you are able to translate it along this direction. So what we will do is uh, we will put it somewhere here and then change our view orientation. Now we click here to get the perfect side view, and then we will fix it somewhere as per our requirement. So this looks fine. We do not need to make any screw mate with this nut because this nut will be fixed in our assembly. So we will just fix it. Once you are okay with the linear position along the y-axis, you can just right click here and click on fix. So now the nut is also fixed. Next, what can we do is we need to align the spring with this temporary axis. So we go to mate again, and this time just click on this temporary axis, and this sketch of the spring that is visible. So now this temporary axis has been aligned with the spring. After this, we need to mate the spring with this top part as well as here the bottom part that will be mated with the nut. And also we need to align these faces. So this face of the cylinder head and this face of the cylinder uh, should be parallel to each other. So we click on parallel so that the rotation of the above part is fixed. Right now we are left with two types of mates. First one is the attachment of spring from the top and bottom, and the second one is the linear movement restriction of this cylinder head. See, it's going out of the cylinder as well as it is overlapping with the cylinder. So we will use advanced mechanical mate in which we can set the linear movement so that it will be restricted to go up and down. So first of all, let's select this part, this face of the spring, and then select the flat surface of this nut. We have already rotated this nut, so now we know that the flat surface is right here. So just select this face. See, the spring is now attached. The coincident made has been applied. Click OK. Now we come out of the mate and we set this view. Now here, since we want it to be in the dynamic shape, that means that when we pull this cylinder head, we want the spring to be pulled at the same time, and when we compress it downwards, we want the spring to be compressed as well. So in order to achieve that, we cannot use the coincident mate. What we need to do is uh, we click here on the spring and click on edit sketch. So this pop-up will ask you to save this assembly. You can save it anywhere and give it any name that you like. Now the assembly has been saved and it will open the drawing for you. So in this drawing, you can see that this is the sketch of the spring that we are editing right now. And here at this point, there is a constraint, coincident constraint. You need to double click it. And then from this menu at the left, you need to delete it. So now this constraint has been deleted. Click OK. And now you are again in the sketch mode. So what you need to do is you need to pick this point right here, which is at the cylinder head. Press Ctrl and then again click on this point, which is at the spring sketch. Both of these points have been selected, and now using the relations, you can define the coincident relation. So now see that the spring has been elongated, the sketch has been elongated, and this is now constrained with the cylinder head. Just click OK and click here to come out of the sketch, and then click again here to go back into the assembly. Now here we can see the dynamic behavior of this spring, whether it's working or not. What I need to do is I need to pull this down a bit and click on this signal button, which is called rebuild. You can also use Control B. So once the rebuild is complete, you can see the spring has been compressed. Similarly, if I pull it again and click on rebuild, the spring has been elongated. So this works fine. The final thing that is left is the uh, distance limitation. For that, we need to go to mates again. And this time we will choose the advanced mate section. In the advanced mate, just click here on the distance. You might also want to set the orientation first. So we will choose this side view. And in this distance, you need to specify the flat surfaces. So this flat surface can be selected at the nut, and at the cylinder head, this flat surface can be selected. So now SolidWorks will calculate the distance between these two faces. Again, you can set the view, and here 1 mm is selected. We just increase it to 300 mm, press tab and see what happens. So at 300 mm, this is the distance between the flat surface of the nut and the flat surface of this cylinder head. So if you are okay with this minimum distance, you can just note it down. And for the maximum distance, you can also try using a hit and trial rule, or you can also check the dimension of these parts. So for the maximum part, we try with the 500 units and see what happens. So see, in 500 units, we are at a safe distance, and this cylinder head is not coming out of this cylinder. So we can just fix it with 300 and 500, or we can also play around a bit. So to see, in order to see the maximum length that the cylinder head can go. So for now, we are setting it to 500 maximum and 300 as minimum. So it will be the linear movement restriction between these two parts. Once you are satisfied with the movements and limitations, just click on OK. Come out of the mates, and here is your assembly complete. You can verify it using this. See, it is not uh, going towards left anymore. This is the limit. You can click on rebuild to compress the spring. Similarly, you can drag it and see this is the maximum distance that you can drag, and then again click on rebuild to see whether the spring is working or not. At this stage, one final touch is remaining, which is to hide these sketches. This line can be hidden. Just click on line and click on hide. And these sketches at the nut are also visible. So just click on this sketches and then click on this I button to hide the sketch. Finally, this circle face is also visible from the sketches. So just right click and click on hide. So all the sketches have been hidden, and the final your assembly is complete. Now the next stage is to create an animation. In order to create the animation, you can also set the scenes, set the background, or change the color of your parts, whatever you like. So let's say we choose the background to be plain white. So this is the plain white, and because of the appearance of the plain white background, you are able to see more bright colors of these parts. So in order to create the animation, what can we do is we go to motion study and set the orientation first. Here, after setting the orientation, you can click on this key and click on replace key. So the start of the animation at 0 seconds, this will be the default view of your assembly. So now the spring is already elongated. What can we do is we can compress the spring. So in order to do that, we will drag our timeline to 2 seconds and then drag it to the left, then click on rebuild. So SolidWorks will save this file and record the animation that from 0 to 2 seconds, this spring will be compressed. You can calculate the results, you can play it again, or you can save the animation. That's all. Thank you.